Okay, so payment operations platforms. Like most people, I don't really think about them much, but they are super important to how the world works today. We're talking about systems that handle, I think it's over $15 trillion in transactions every year.
Yeah. 15 trillion
Yeah.
globally.
Which is, I mean, that's more than the GDP of most countries.
Yeah.
Think about that for a second. And these are the systems that power, like, basically every digital financial interaction that we have. Like, when you're buying stuff online
Yeah.
or when multinational corporations are settling these huge deals, that all goes through these platforms.
Right. And what's really fascinating of this topic is that it's not just like a simple, I'm hitting a pay button and the money disappears. These systems are so sophisticated in terms of what they're doing behind the scenes to like manage fraud,
Yeah. Yeah.
to make sure you're complying with all the crazy regulations around the world, and then also just like reconciling all those payments.
Right.
Like making sure all the money is accounted for. Like if you think about the scale of $15 trillion.
You cannot have even like a small error.
Right.
It's really the backbone of the whole digital economy.
Exactly. And you've curated a fascinating set of materials for this deep dive.
Thanks.
We've got some really technical deep dives into like the architecture and workflows of these platforms. We've got discussions about some of the specific companies and technologies involved. And then we've even got this kind of surprising YouTube strategy about managing online queues, which I'm really interested to see how you tie that in.
Yeah, we'll get to that.
Okay.
It'll be fun.
So our mission, I guess, with this deep dive is to give everyone listening a really clear understanding of the inner workings of these platforms.
Right.
Like, what are the core components? How do they all interact?
Yeah.
What are some of the things that most people just don't even realize are happening behind the scenes every time they buy something online?
Yeah. I think there's a lot of like aha moments in this topic and a lot of like really fascinating technologies that I think people don't know about. So where do we even begin with something this intricate? It seems like a really good place to start is with the basic building blocks.
Yeah.
Like the architecture of these platforms, it's not just one giant piece of software, right?
It's not. No. Like in the modern way that these payment platforms are built, they typically employ a four-layer architecture.
Okay.
And it's kind of like, think about it like a skyscraper.
Okay.
Where you've got, different floors, and each floor has a specific purpose.
Okay.
But they all have to work together for the building to function.
I like that analogy. Okay, so what are the four key layers of this payment platform skyscraper?
Okay. So the top layer, or I guess the first layer, if we're going from the top down, is what's called the presentation layer. And this is basically the interface that the customer interacts with. So
Yeah.
this could be the payment page on a website, or it could be the tools that are embedded within a mobile app.
Right.
So all those nice mobile SDKs that make it super easy to pay within an app.
Yeah.
That's all part of the presentation layer. Now, one really crucial function that happens at this level is what's called tokenization.
Okay.
So when you enter your credit card details on a website or in an app,
Right.
the system will actually replace that sensitive data with a unique token, like a randomized code.
Okay.
It's usually what's called a UUID token.
UUID?
Yeah, universally unique identifier.
Okay.
So it might look something like, TikTok _ 19S7, a 2EDF or something like that.
Right. Okay.
Just a random string of characters.
So, like, that's what the merchant actually sees then?
Exactly. So the merchant never actually sees your real credit card number. They only see this token.
Yeah.
And this token is then used to process the payment.
Okay.
So your real credit card information is stored in these like super heavily protected vaults
Okay.
that are, PCI DSS certified. And PCI DSS is the payment card industry data security standard.
Oh, right.
Which is like a really important security standard for anyone who's handling credit card data.
Right, of course.
And here's the thing. By using tokenization, the merchant can actually reduce their scope of PCI compliance by up to 92%.
92%.
Yeah, 92%.
That's huge.
It's massive. It basically means that they have to worry about securing a much smaller part of their system.
Right.
Because they're not actually storing that sensitive card data. So it just drastically reduces the complexity and the cost of PCI compliance.
That makes a lot of sense. Okay, so that's how the platform protects the customer's data.
Right.
But what about the business that's using the platform? Like, what do they see?
Yeah. So the presentation layer, also typically includes these dashboards for the business to use.
Okay.
And these dashboards will track all sorts of key performance indicators, sometimes as many as 150 different KPIs.
150?
Yeah, it's crazy.
What kind of things are they tracking? Like, I would imagine authorization rates would be a big one.
Yeah, authorization rates for sure.
Like the percentage of payments that actually go through.
Exactly. And then also things like chargeback rates,
Okay.
which can be a sign of potential fraud or customer issues. But it goes way deeper than that.
Great.
You can track the performance of different payment methods in different regions. So, for example, they might be able to see that digital wallets are super popular in one country,
Right.
but not so much in another. And that could inform their strategy for, how they promote different payment methods to their customers.
Okay.
Or they might be able to see that people are dropping off at a certain point in the checkout process.
Right.
And then they can go in and try to optimize that part of the flow. So it's really about having like super granular visibility into every aspect of the payment experience.
Right.
And then using that data to make better decisions and ultimately increase revenue.
Makes sense. Okay, so we've got this top layer, the presentation layer, which is like what the customer sees and what the business sees.
Right.
What's the next floor down in our skyscraper?
Okay, so the next layer is what's called the orchestration engine.
Okay. Orchestration engine.
Yeah. And you can kind of think of this as the brain of the whole system.
Yeah.
It's the part that makes the decisions about how each individual payment should be routed and processed. So it doesn't just like blindly send every payment to the same place.
Okay, so it's deciding like where each payment should go.
Exactly. And it's making those decisions based on a whole bunch of different factors. We're talking about potentially over 50 different parameters.
Wow, okay.
So things like the currency being used, the risk score of the transaction, and even like the past performance of the different payment service providers or PSPs that the platform is connected to.
Okay.
So for example, the system might know that for European card payments, Adyen has a really high success rate historically.
Okay.
So it will prioritize routing those payments through Adyen.
Yep.
But for a payment that's using Brazil's local PIX system, it might route that through a local acquirer in Brazil that has specific expertise in handling those types of payments.
Right. Makes sense. So it's kind of like, I'm thinking of Cloudflare, how their network routes internet traffic like for the fastest speeds and reliability.
Exactly.
It's kind of doing the same thing, but for payments.
It's the same principle. It's all about optimizing the flow of transactions and making sure that they're processed as efficiently and reliably as possible.
Yeah. So the orchestration engine sounds really smart.
Yeah. It's pretty sophisticated.
So what happens after it's made its decision about where a payment should go?
So that's where the third layer comes in. It's called the processing core.
Okay.
And this is the part of the system that actually executes the settlement workflows with the PSPs and the banks. So this is where the actual movement of funds begins.
Okay.
And there are two really key technical things that happen here that I think are worth mentioning.
Okay.
The first is the use of idempotency keys.
Idempotency keys.
Yeah. So imagine you're buying something online.
Yeah.
And you accidentally double-click the pay button.
Right.
Or your internet connection flickers or something.
Happens all the time.
Right. So the same payment request gets sent twice.
Right.
An idempotency key basically ensures that you only get charged once.
Oh, okay.
So the system recognizes the key from the first attempt, and then it prevents a duplicate charge. So it's like a safety net.
Right. That's really important.
Yeah, super important. And then the second thing that happens is the use of two-phase commits.
Okay.
And this is for transactions that involve multiple different providers. So for example, if you're using a digital wallet to pay a merchant who's using a different payment gateway,
Okay.
the two-phase commit basically makes sure that the entire transaction either succeeds across all the parties or it fails completely.
Right. So there are no loose ends.
Right. You don't want a situation where the money leaves your wallet, but it doesn't reach the merchant.
Right.
Or vice versa. So the two-phase commit is kind of like a coordinated agreement where everyone has to confirm their part of the transaction before it's finalized.
That makes a lot of sense. Okay, so we've gone from what the customer sees to the brain of the system to the engine that actually moves the money.
Right.
What's the final piece of this puzzle?
Okay. So the final layer is the reconciliation mesh.
Reconciliation mesh.
Yeah. And this layer is all about making sure that everything balances out perfectly.
Okay.
So it's constantly verifying the integrity of every transaction by comparing the platform's own internal ledgers
Yeah.
against the statements from the banks and the reports from the PSPs.
Okay.
And this is happening continuously. Like some platforms will actually do this hourly.
Hourly?
Yeah, they'll do like these hourly reconciliation sweeps.
Well, that's impressive.
Yeah. And they'll flag even the tiniest discrepancies.
Yeah.
Like if there's a difference of a few cents,
Wow.
they'll want to know why.
So it's like having an army of accountants working around the clock.
Exactly. It's all about maintaining trust and accuracy.
Right. Because when you're dealing with $15 trillion, even a tiny error could be a really big deal.
Right.
Okay, so we've got a good understanding now of the 4 layers of this architecture.
Okay.
But I think it would be helpful to actually walk through an example.
Sure.
So let's say I'm buying a $100 item online.
Okay.
And I'm using my credit card. Can you walk us through the journey that payment takes?
Yeah, absolutely. So the first step, as we discussed, is tokenization.
Right.
So when you enter your credit card details on the website or in the app,
Yeah.
those details are immediately replaced with that unique token.
Okay.
And this all happens within a secure environment. So your real card number never actually touches the merchant's systems.
Right. So it's locked away safely in that digital vault you were talking about.
Exactly. And that just makes things so much easier and safer for everyone.
Okay. So once that token is generated, what happens next?
So the next step is risk assessment.
Okay.
The platform is going to use these sophisticated machine learning models to analyze a whole bunch of different data points. We're talking about potentially up to 137 different features.
137 features?
Yeah, that's a lot.
What kind of things are they looking at?
So they're looking at things like your device fingerprint.
Device fingerprint.
Yeah. So this is information about your device, like your operating system, the browser you're using, any plugins you have installed.
Okay.
They're also looking at your behavior on the site. So like how quickly you filled out the forms, if your mouse movements are unusual.
Wow. Okay.
They're also checking to see if you're using a proxy server or a VPN.
Right. Because those can be used to mask your location.
Right, exactly.
Yeah.
And then they're also looking at things like your IP address, your geolocation.
Okay.
So they're building this really detailed profile of you and the transaction.
Wow.
And then based on all that information, they're going to assign a risk score to the transaction.
Okay. So if the risk score is too high, what happens?
So if the risk score is too high, it can trigger a manual review, which means that a human analyst is going to take a look at the transaction and try to determine if it's legitimate or not.
Mm-hmm.
And there could be like 85 different scenarios that would trigger this kind of manual review.
85 different scenarios.
Yeah, it's pretty comprehensive.
So they're really looking for anything that's out of the ordinary.
Exactly. They're trying to catch any potential fraud before it happens.
Makes sense. Okay, so let's say my payment passes this risk assessment.
Okay.
What happens next?
So now the orchestration engine comes into play.
Right.
Remember, that's the brain of the system.
Yeah.
So it's going to look at all the different PSPs that the platform is connected to.
Okay.
And it's going to decide which one is the best option for processing this particular payment.
Okay. So how does it make that decision?
So it looks at things like the current performance of each PSP,
Okay.
like what their success rates are, what their fees are. So for example, let's say that Adyen has a 98.7% success rate for US dollar transactions, and they charge a 15-cent fee.
Okay.
And Stripe has a slightly higher success rate of 99.1%, but they charge an 18-cent fee.
Okay.
So the orchestration engine is going to use these complex algorithms to figure out which PSP is going to give the platform the lowest cost per successful transaction.
Right. So it's not just about getting the cheapest fee.
It's about finding the right balance between cost and reliability.
Right.
And it's making these decisions dynamically based on real-time data.
Wow. Okay. So once the payment is routed to a PSP, what happens then?
So then we get to the settlement phase.
Okay.
This is where the money actually moves.
Right.
So the funds flow through the PSP's network to the merchant's bank account.
Okay.
But at the same time, the platform's internal ledger service is recording every aspect of the transaction.
Okay.
And this is where that triple entry accounting system that you mentioned comes in.
Right. So it's not just a debit from my account and a credit to the merchant's account.
Right. There's a third entry for the platform's fees.
Okay.
So for your $100 purchase, let's say the platform charges a $3 fee.
Okay.
So there would be a $100 debit from your wallet, a $97 credit to the merchant's account,
Okay.
and a $3 credit to the platform's account.
Right.
And all of this happens within a single transaction.
So it's all linked together.
Exactly. It's atomic. So either all of it happens or none of it happens.
Makes sense. Okay, so the money's moved, the books are balanced.
Yeah.
What about fraud?
Yeah, so fraud prevention is a huge part of what these platforms do.
Right.
And they employ these multi-layered defense systems to catch fraud at every stage of the process.
Okay.
So the first layer is pre-transaction screening.
Okay. Pre-transaction, so before the payment even happens.
Exactly. So they're trying to identify potential threats early on.
Okay.
So they're doing things like device fingerprinting.
Right, we talked about that.
Yeah. So looking for suspicious devices that have been associated with fraud in the past.
Okay.
They're also doing behavioral analysis.
Mm.
So looking for unusual patterns in how the user is interacting with the payment page.
Right.
Like, are they typing really fast? Are their mouse movements erratic?
Okay.
And then they're also checking to see if the user's connecting through a proxy server or a VPN.
Right, just to hide their location.
Exactly.
Okay.
So if the transaction passes all of these checks, it moves on to the next layer, which is transaction analysis.
Okay. Transaction analysis.
And this is where the platform really brings out the big guns.
Okay.
So they're using a rules engine to evaluate the transaction against a whole bunch of predefined policies.
Okay.
We're talking about potentially over 250 different rules.
Wow. 250 rules.
Yeah.
Like what kind of rules?
So, for example, a rule might be that any transaction over $500 from a newly registered account gets automatically declined. Or if the shipping address is in a high-risk country, the transaction might get flagged for manual review.
Makes sense.
And in addition to these rules, they're also using neural networks.
Neural networks.
Yeah. So these are AI systems that have been trained on massive data sets of historical transactions.
Yeah.
Both legitimate and fraudulent.
Right.
And they can use this data to predict the likelihood that a new transaction is fraudulent.
Wow.
So it's like having a highly experienced fraud investigator analyzing every single transaction in real time.
So they're throwing everything they've got at this problem.
Yeah, fraud prevention is a constant arms race.
Okay. So let's say a payment gets through all of that.
Okay.
It's been authorized, the money's been moved. Is that the end of it?
Not quite. There's still one more layer of defense, which is post-transaction monitoring.
Post-transaction.
Yeah. So even after a payment has been approved, they're still watching for any suspicious activity.
Okay.
So they're doing things like using entity resolution graphs.
Entity resolution graphs.
Yeah. So these are like maps that show the connections between different transactions and different users.
Okay.
And they can use these graphs to identify potential networks of fraudsters.
Right. So if someone's using multiple accounts or stolen credit cards.
Exactly. And
Yeah.
then they're also using automated systems to respond to chargebacks.
Okay. Chargebacks. That's when a customer disputes a payment, right?
Right. So the platform can automatically gather evidence and respond to the chargeback if they believe it's unwarranted.
Okay.
And there are companies like Unipause.
Unipause.
Yeah. They're doing some really cool stuff with real-time consortium data sharing.
Real-time consortium data sharing.
Yeah. So basically, if one merchant using their system detects a pattern of a stolen credit card being used,
Okay.
that information is shared instantly with all the other merchants on the network.
Wow. So they can all block that card.
Exactly. And that just makes it so much harder for fraudsters to operate.
That's really impressive. Okay, so we've talked about how the platform handles the money and how it protects against fraud.
Right.
What about all the regulations?
Yeah, so compliance is another huge part of what these platforms do.
Right.
And luckily, they're able to automate a lot of this.
Okay, good. Because that sounds like a nightmare otherwise.
It would be.
Okay.
So, for example, for sanctions screening, they'll integrate with global databases like WorldCheck and the OFAC lists, the Office of Foreign Assets Control.
Okay.
So these lists contain information about sanctioned individuals and entities.
Okay.
So the platform automatically scans every transaction and every user against these lists to make sure they're not doing business with anyone they're not supposed to.
Right.
And then for tax compliance, the system can automatically calculate VAT and GST.
VAT and GST.
Yeah, value-added tax and goods and services tax.
Right.
In over 140 different jurisdictions.
Wow.
And they can generate localized invoices that comply with all the specific legal requirements in each country.
So they're handling all the tax paperwork.
Yeah. And in some cases, they can even handle the direct filing of tax returns.
Wow. Okay, that's really helpful. What about data privacy?
Yeah, so for data privacy, they'll implement features like automatic masking of personally identifiable information in logs.
Okay.
And they'll enforce data retention policies, so like deleting user data after a certain period of time. And they'll also do regular breach simulations to make sure their systems are secure.
Okay. So they're taking data privacy seriously.
Absolutely.
Okay. So we've covered the architecture, the transaction flow, fraud prevention, compliance.
Right.
Let's go back to the reconciliation engine for a minute.
Yeah.
Like, how does it actually make sure that everything balances out?
Yeah, so the reconciliation engine uses this four-dimensional matching process.
Fully dimensional.
Yeah, so the first dimension is amount validation.
Okay.
So they're comparing the settled amounts against the initially authorized amounts.
Right.
And they're usually allowing for a tiny tolerance, like plus or minus 10 cents, to account for rounding differences.
Okay.
And then the second dimension is timeline alignment.
Okay.
Yeah.
Timeline alignment.
Yeah, so they're making sure that the dates of the transactions in the platform's ledgers match up with the dates reported by the banks and the PSPs.
Right.
And this is especially important for cross-border transactions.
Right. Because those can take a while to clear.
Exactly.
Yeah.
And then the third dimension is fee verification.
Okay.
So they're auditing the fees that the PSPs are charging to make sure they're in line with the contracts.
Right.
And some platforms are actually starting to use smart contracts for this.
Smart contracts.
Yeah. So these are like self-executing contracts that are stored on a blockchain.
Okay.
And they can automate the fee verification process and make it more transparent.
That's interesting.
Yeah. It's a really cool use case for blockchain technology.
Okay.
And then the final dimension is FX rate checks.
FX.
Yeah. Foreign exchange.
Right.
So they're making sure that the exchange rates that were applied during the transaction are accurate. And they're doing this by comparing them against benchmark rates from reputable sources like the European Central Bank.
Okay. So if they find any discrepancies during this whole process, what happens?
So if they find any discrepancies, the system can automatically take action.
Okay.
So it might file a dispute with the PSP, it might propose adjustments to the internal ledgers, or it might generate a report if it thinks there's a compliance issue or a systemic problem.
Right. So it's not just about checking the books.
Right. It's also about preventing problems and making sure everything is running smoothly.
Okay, so these platforms are clearly handling a massive volume of transactions.
Yeah.
Like, how do they manage to scale to that level without breaking down?
Right. So they use a combination of horizontal scaling strategies.
Okay.
So one key technique is database sharding.
Database sharding.
Yeah. So basically, they split the data up across multiple different databases.
Okay.
So instead of having one giant database that has to handle everything,
Right.
they have like a bunch of smaller databases
Yeah.
that each handle a portion of the data.
Okay. And that makes it faster.
Yeah, it makes it much faster and more efficient.
Okay.
And then they also use event streaming platforms like Apache Kafka
Okay.
to handle all the real-time events that are happening.
Like what kind of events?
So things like payment status updates, fraud alerts, things like that.
Okay.
And then the whole system is usually built using microservices.
Microservices.
Yeah. So these are small, independent units of functionality that can be scaled up or down independently.
Okay.
So if one part of the system is getting overloaded,
Right.
they can just spin up more instances of that microservice to handle the load.
Okay. So it's all about being flexible and adaptable.
Exactly.
Okay, so they've got all these mechanisms in place to handle the volume.
Right.
But what about failures?
Yeah, so failures are inevitable in any complex system.
Right.
So these platforms have to have robust failure recovery protocols. So we've already talked about how idempotency keys prevent duplicate charges in case of retries,
Right.
but they also use things like compensating transactions.
Okay.
So if a payout fails for some reason after the money has already been debited from the customer's account,
Right.
the system can automatically reverse the transaction and credit the money back to the customer.
Okay.
And then they also use eventually consistent views to provide a more responsive user experience.
Eventually consistent views.
Yeah. So basically this means that the user might see an initial status update like processing, even though the transaction isn't fully complete yet.
Okay.
But behind the scenes, the system is still working to finalize the transaction.
Right. So it's just giving the user a quick update.
Exactly.
Yeah.
And it avoids making them wait for every single step to finish before they see any feedback.
That's good. Okay, so we've covered a lot of ground here.
Yeah.
Like, what are some of the exciting new innovations that are happening in this space?
Yeah, so there's a lot of cool stuff happening right now. One big trend is the integration of blockchain technology.
Okay, blockchain.
Yeah. So people are looking at using smart contracts for things like escrows.
Uh-huh.
So holding funds until certain conditions are met.
Right.
They're also looking at using central bank digital currencies, or CBDCs, for settlements.
Okay, CBDCs.
Yeah. So these are digital currencies that are issued by central banks.
Right.
And they can potentially make settlements much faster and more efficient.
Okay.
And then people are also exploring the use of DeFi protocols for yield optimization.
DeFi.
Yeah, decentralized finance.
Okay.
So basically, this is about using blockchain-based platforms to earn interest on idle funds.
Okay. So it's like putting your spare change in a high-yield savings account.
Yeah, kind of,
Yeah.
but with much higher potential returns.
Interesting. Okay, what else is happening?
So another big trend is the use of AI and machine learning.
Okay.
So this is being used for things like predictive routing.
Predictor routing.
Yeah. So basically, they're using AI algorithms to forecast potential problems with different PSPs.
Okay.
Like if a PSP is likely to have downtime or experience performance issues,
Right.
and then they can automatically route traffic away from that PSP to a different one.
Wow.
And they're also using AI for things like dynamic pricing.
Dynamic pricing.
Yeah. So basically, they're adjusting the fees that they charge based on real-time market conditions.
Okay.
And then they're also using AI for conversational compliance.
Conversational compliance.
Yeah. So they're using chatbots to help merchants understand and comply with all the different regulations.
So instead of having to read through a bunch of legal documents.
Exactly.
Okay, so it sounds like the future of payment operations is going to be even more automated and intelligent.
Yeah, I think that's definitely the trend.
Okay, so let's say a business is looking to implement or upgrade their payment platform.
Okay.
What are some best practices they should keep in mind?
Yeah, so when you're migrating from an existing system to a new one, it's really important to do it gradually.
Okay.
So one popular strategy is called the strangler pattern.
Strangler pattern.
Yeah.
That sounds a little bit aggressive.
Yeah, it's a funny name.
Okay.
But basically what it means is that you slowly start routing traffic to the new system while still keeping the old system running.